And if nothing cancels in the problem, then you're not going to have any removable discontinuities. There's nothing to remove. So there are no holes in that first problem that we did. All right, so let's look at the next problem and see what's going on there. The next problem and your job, our job, is to sketch it showing all the asymptotes, holes, and intercepts. Okay. I'm going to need a better marker than that. So what might we do first?
Factor.
Factor. I think I would factor. Because once again, guys, the only way you're going to know if you have a hole or not is to cancel something out, and the only way you can cancel is to factor first. So I'm going to go ahead, even though things do not look promising here, I'm factoring, and guess what? I am not going to be able to cancel, which simply means that, again, I have a problem that doesn't have any holes. That's okay. Does it have any asymptotes? It has a lot of asymptotes. It has vertical asymptotes at x equals 2 and x equals negative 2. I know we've talked about this before. Talk about it again. Vertical asymptotes are cannot be's. And we know when we look at this problem that x cannot be 2 or negative 2. Right? Now, let's look at the original problem. Do we have a horizontal asymptote? Why, yes, we do. It is y equals 1. Now, what about intercepts? Well, remember, intercepts are where you cross the axes. So one of the variables has to be 0. If we let x be 0, where is our y-intercept?
9/4.
9/4. Let's see, 9/4. If we let y be 0, don't overcomplicate this, guys. The only way a fraction can be 0 is if its numerator is 0. So what are my x-intercepts? I have 2 of them.
-3 and 3.
Negative 3 and positive 3. These are the only places, these black dots I have, are the only places that your curve can touch an axis. So whatever else is happening in this picture, you aren't going to cross an axis anywhere except there. Lucy?
So is there the asymptote at y equals 1 because there's no coefficient in front of the x values?
Yep, it's x squared over x squared. 1 over 1.
Okay, and if there was coefficients in front of it, how would you determine that?
It'd be 2 over 1.
Okay.
Or 2 over 3 or whatever they were.
Okay.
All right. Any thoughts on what this thing looks like?
Probably good.
Remember, you can go with your gut or your past experience. That's perfectly okay. But if you're ever in doubt, you can also plot some extra points, right? Calculators are off limits here. We're not graphing on our calculator. But you can always plot some extra points if you're not sure. Maureen?
I would say that, but over there, it's gonna go like that,
I think you're exactly right.
and then the opposite way in that top right section.
Up
So
here?
like, yeah.
Okay, now be careful. I don't think it can be up here because I got a point right there,
Oh,
right? I got a point right there. That point's gotta be part of the curve.
oh, then it's just reflected.
So it's just like this.
Yeah.
Keep in mind as you're trying to visualize this, keep in mind mind that the asymptotes frame the picture. Okay? So the curve is going to approach its asymptotes. Perfect. All right? What about the middle part?
So that would just be like
Pardon the interruption. Could you please send Grant Bettner?
I had him last period. I had him last period.
Okay, thank you.
Okay. So what's going on there in the middle?
like just a smile, basically.
Yeah, really two choices, kids. It either has a parabola-like shape, not necessarily that being the minimum, I don't know, but some kind of parabola-ish shape in there, or it has kind of a cubing shape. It can't have a cubing shape this time, because if it did have a cubing shape, what would have to happen right here?
It would go through the end.
It would have to cross the axis, and it can't. Now, I do want to point out that you can actually cross a horizontal asymptote, because horizontal asymptotes are end behavior asymptotes. In other words, they are limits. Horizontal asymptotes matter when x is really big, negative or positive. It is common to cross horizontals. However, I can't cross the x-axis except here, so I know it's not that shape in there. I know it's got to be that. You will see pictures from kids where you have a situation where you're like here and here and like this. That's very common. That happens. You can cross a horizontal asymptote. Cannot cross the x-axis except at the intersection, which you've already done. Okay, well that was interesting. Let's see this next one. Uh-oh, we got some action here.
This force. That one doesn't have holes, but does it have discontinuity?
Oh yeah, it's got non-removable discontinuities right here and here. Yeah, vertical asymptotes are, your book calls them infinite, I call them non-removable.
Alright.
Yeah, remember, Oliver, if you are lifting your pencil, you are not continuous. Okay, boys and girls, this one is just full of excitement. Here we go, step one. What are we gonna do?
Factor.
Factor, right? We're gonna factor. What are we doing on the top?
Taking out an X.
Taking out an X. And then, can't we go farther? X minus 2 plus 1. And how about the bottom? Plus 3 minus 2. How about that, everybody? You okay with that? Well, I see a cancellation. So my problem is really going to just boil down to being x plus 1 over x plus 3. Would you agree with that? But this factor that I canceled out still has an impact in the picture. It's going to graph as a whole. Whatever factor canceled out, that's where your removable discontinuity is. So it looks like it's where x is 2. Right? That's what I canceled out. How will I get the y?
Plug it in.
Plug it in. So I have 2 times 2 plus 1 over 2 plus 3. So what is that? 6 over 5? So I'm going to go ahead and plot that right now before I forget. So 2 6 over 5 is my whole. Now the curve is going to go through that. So whatever shape I end up having, it's going to go through that point or skip over that point. Everybody with me so far? Do we have any vertical asymptotes? Now, focus your beady little eyes right here, folks. Do we have any vertical asymptotes? -3. Your discontinuities, kids, are either going to be removable or non-removable, not both. So don't go back and look at the original problem and say, oh, I have an asymptote at 2. No, you don't. That's gone, right? This is where you now are basing everything, right here. So we got a vertical asymptote at -3. Let's talk about intercepts. If I let y, or let's let x be 0 first, it's easier. If I let x be 0, if x is 0, what's y?
0, 1/3.
Also 0. If I let y be 0, think of this as being a 0 here. The only way a fraction can be 0 is if its top is 0, so it looks like x has to be either 0 or -1. Very strange. Now, what about an end behavior asymptote? What about a horizontal asymptote? Take a look at your original problem. We talked about this earlier in the year.
0x cubed.
What?
You need to put 0x cubed on the
Yeah,
bottom.
and what happens when I put a 0x cubed down there?
Zero undefined.
It's, so what does that mean?
No.
There is no horizontal asymptote, but there is an end behavior asymptote. Kids, horizontal asymptotes are a special version of end behavior asymptotes. Not every end behavior asymptote, that is what happens at the ends of the picture, is going to be horizontal. They can be different things. To find your end behavior asymptote, I'm going to come back to my problem. I'm going to go ahead and FOIL or distribute it back out. And I'm going to do that division. I'm going to actually divide that. So with synthetic division, in the box will go a -3. And I'll have 1, 1, 0 for my dividend, right? So I'll bring the 1 down, I'll start doing my division. How does that work? Did I divide right? Okay, so what's left?
6 squared.
No. Not, this was x squared, so this is gonna be x. So what's left is y equals x minus 2, and then a remainder of 6. Now, when you do your division to find an asymptote, you don't care about the remainder. All you care about is the quotient. This, my friends, is your end behavior asymptote. So you're going to sketch the line where y, starting with a y-intercept at -2 and a slope of 1. So up 1 over 1, up 1 over 1. So this, in our last picture, the asymptote was horizontal. Not now. This one is a slant, what's called a slant asymptote. And the slant asymptote is found by doing the division. And that was necessitated because the power on top of the fraction was bigger than the power on the bottom. So we had to divide.
What is this 6? Like the remainder of 6, is that your,
That's nothing. It's ignored. Don't care.
oh,
The asymptote is x minus 2. Just that part right there. Yes? I'm dividing this right here. 1, 1, 0. I'm doing synthetic division. So it's this divided by this. Now I gotta figure out what in the heck this thing looks like.
wait, how did you know which points it went through? For the end behavior asymptote?
I graph the line as a y-intercept of -2 and a slope of 1. So I just graph the line like regular.
Is the point -1, 0 by making the y 0? And you just said,
Mhm.
okay,
That's how we get this intercepts.
okay.
Now, any idea at all what this thing looks like? Keep in mind that the vertical asymptote splits it into 2 halves. So something's happening on the left of the asymptote and something's happening on the right of the asymptote. Any thought on what's happening on the left? No clue?
Is it
I'll tell you,
On the
right
bottom?
down here, it's like this. Now, how do I know that's what's happening over there? Well, I want you to remember, the asymptotes frame the picture. So on the left side of this, I either have to be down here in this little section, or I have to be up here, right? Well, what would be wrong with drawing this? There's no intercept. So keep in mind, you only have 2 choices. It either looks like this, or it looks like this. It can't look like this, so it must look like that. Now, I'm approaching this from a logical standpoint. If that's confusing you, then you're gonna set up a T-chart. This is -3, so you're gonna try -4, -5, -6. You're gonna plot some points, and you're gonna find out they're right down there. Now, what in the world is happening on the right side? Well, again, you only have 2 choices. You're either gonna be graphing up here, or you're gonna be graphing down here, right? Those are your only 2 choices. You got points up here, right? So I think I'm gonna be graphing up here.
like a parabola shape?
Okay, so it comes down like this. And then when it gets here, I don't know what it does. Could it bounce up? Probably not. It probably goes below. But if I want to check, could I check that in there? Could I maybe put in to my T-chart like -1/2 and see if it's positive or negative? I think it's this right here, and I don't want to take up the time to check. I'm very confident that's what it is. But it could be a bubble up, and you would just want to double check -1/2, plot that point, and see what you get. Strange picture.
So, like, besides, like, logically, but do we know that it's a parabola shape because, like,
It isn't a parabola. I mean, it has that
like
shape.
that shape
Yeah.
because, like, the factors of, like, x and x plus 1, like, if you put them in.
No, it has to look like this because it has to be framed by these 2 asymptotes. It has to contain these 3 points, and it can't cross the axis anywhere but where these 2 points are right here. So it's process of elimination. There isn't anything else that it could look like. It can't be down here. It could be down here, but it can't because it's there. I don't have intercepts there. So it has to be up here, picking up all of these points, getting framed by its asymptotes. All right, next. Another deal. All right, what do you wanna do to start this next one?
Factor by grouping.
Okay, we need to factor,
Oh,
and,
it's a minus. Maybe a smaller exponent.
actually, I heard somebody say factor by grouping. And actually, that does factor by grouping, but you'll need to remember how to do cubes. If we wanted to factor this by grouping, we'd have to group the first and last and the middle two. And if we did that, the first and last are the sum of cubes. That's your soap thing. Remember how that works? How does that factor? X cubed plus 1. X plus 1. X squared minus x plus 1. Same. What's that
Opposite.
say? Opposite.
Always positive.
So if you chose to factor by grouping, that's how you would start. You would have to group those two. Then in the middle, you could take out a minus 3x. Nope, that would be a minus. Oh crap, that isn't gonna work.
Wait, how is that the factoring? What about the flip?
Oh, that isn't gonna work, so I just did all that for nothing. I thought for sure I could do that, but apparently I can't. So factoring by grouping isn't gonna work, so what am I gonna do? PRRs, and luckily there aren't very many. So let's see. Let's try negative 1. Let's try negative 1.
You can go to nether.
No, that doesn't work.
Well, maybe. Makes your force was too good.
I don't think 1 works either, does it?
Negative 1. I might have
Wait,
done
are
it
you
wrong,
using
but I think
this?
negative 1
Did
works.
I copy this right?
I think.
Help me out here, I'm trying to find something that works.
Negative 1 doesn't mean it's.
Negative 1 doesn't work. Does work, you say, or doesn't work?
Does not.
I don't think 1 does either, because I just did 1, and it didn't work.
You put that sign, make it.
Then it does cross the x-axis.
Well, it doesn't cross the x-axis with a rational root.
Yeah, right.
There could be an an irrational.
But we'll be able to grab it.
Well,
Wait, where is
let's see how far we can get with it. We know it has a vertical asymptote at 1. We know it has a y-intercept at -1, right? We couldn't find the x-intercepts. How about an end behavior asymptote? How do I find an end behavior asymptote? I'm gonna have to do a division. And what in the world is this end behavior asymptote going to look like? It's going to be a parabola. So, we knew we had a vertical asymptote at 1. We knew we had a y-intercept at -1. And now I am finding my end behavior asymptote, so I just did the division in the problem. Ignoring the remainder when I find the asymptote. And that's what I got. So this time,
Can you factor?
my asymptote is a parabola. And isn't this? So it's the parabola vertex here. That's my asymptote.
How did I get?
Now, I think I'm going to do a quick check on something here. We're unable to factor that. No matter how we tried, we were unable to factor it. So I'm gonna check to see about my kind of roots that I might have. I can't find them without my calculator, but I think I'm gonna check on the nature of those solutions. So how many sign changes in the problem as it stands?
No, 2.
2. And if I put in a negative, there's 1. So I don't know where, but I know for sure I cross the x-axis 1 time on the negative side, right? So somewhere over, I have no idea where it is. I mean, somewhere over here, there's a negative 0. So keeping in mind that the curve has to be contained by its asymptotes, it has to contain that point for sure, and then some other point on this axis over here. Does a shape like this kind of make sense to you? Keeping in mind that you have to follow your asymptote off the page. You have to follow this asymptote off the page. And you gotta contain that point across the x-axis someplace. That's, I think, what that looks like. Now that's the left side of the asymptote. Now, I want you to use your noggins here. On the right side of the asymptote, I have no points, for sure. But I know I have to follow the vertical asymptote off the page. So it's either coming down this way or it's coming up this way. I know it must follow the horizontal asymptote, or in this case, the parabola asymptote,
It's 2.
off the page. So it's either gonna follow it up this way or it's gonna follow it up this way. I don't know if I cross the x-axis or not, but if I do, I have to cross it twice. So keeping all that in mind, what do you think this looks like in here?
It probably doesn't cross at all.
It doesn't cross at all. I think it looks just like this. Now, how could I check that? Instead of sitting there saying, how could you check that?
Plug in a point.
You could build a T-chart. That's 1, so maybe try 2, and 3, and 4, and see what happens to those points. Liam?
So on the left side, does that look like a cubic function?
Probably not. I kind of drew it that way. I'm not exactly sure what the curvature in there is. So yeah, maybe, I don't know, it has to follow that parabola, so it's gonna, you know, have a parabola shape up on that end, and it's gonna become linear on this end. So somehow it has to approach both of those things. Yes, so now let's actually graph it on the calculator and see how close we get to the reality.
Is it possible to graph imaginary roots?
came pretty darn close, right? So let's think back, what were all the things we thought about as we were doing this problem? First, we tried to factor, right? And that did not work out. So ultimately, what did I do this for?
See how many
To
times across the
see where I might cross the x-axis? Because I couldn't have figured out from the factors. That's normally where I would get that. I couldn't get it from there. So this didn't tell me where they were, but this was a good thing. And then, I had to do my end behavior asymptote, because once again, the power on top was bigger. So that meant I wasn't gonna have a horizontal asymptote. So I did the division, actually just did the long division, or synthetic division, and came out with my asymptote. And then I just had to sit and think and put all the pieces together. And if that didn't work for me, I would build a table of values and just plot some points, random points. So I had something to connect. All right, one more.
Wait, this is for, how did you get 2 or 0 positive deals if there's only one sign change?
It goes from positive to negative and from negative to positive. The times the sign changes.
Okay.
All right, here we go. Can we factor? Okay, but that does not help. Well, actually, it helps, but that does not cancel. So that means I will have no holes. That's fine, that's fine. What do I have? I have a vertical asymptote at -2, x equals -2. To get my end behavior asymptote, I'm gonna have to divide because again, the power on top is bigger. So I'll divide. And ignoring the remainder, where is my end behavior asymptote? Y equals X. Well, I should be able to find my intercepts. Where are my intercepts? -3 and 1 are my X intercepts. And then my Y intercept is -1.5, -3.5. Oh, compared to the last one, this one's a cinch. Your vertical asymptote splits your picture. What's happening on the right side? Or left side, I mean, this is left. What's happening on the left side? Isn't it just coming down like this and going up like that? Remember, it's gotta be framed by its asymptotes. It's gotta contain that point. Now, what's happening on the right side of the asymptote? It comes down like this. It actually connects that one and follows on up like that. I'm not sure about this connection right here. Yep, it's gotta contain those 2 points and be framed by the asymptote.
2 over 2.
Oh, boy.
So 2-6 homework, you're gonna get to do some graphing on your own, that is due on Thursday. So 2-6, get your graphing done on Thursday.
This board.
All right, on to 2-7, here we go. We're gonna solve some equations. All right, guys, time to focus, let's go. Here we go. Not graphing, just solving. So what would you recommend?
Multiply by X.
Multiply by X. Now, do keep, I think that's a great idea. That's exactly what I would do. I think that's a marvelous idea. Then I would get it set equal to 0. And then it's a quadratic, so I'm gonna do something. But I want you to keep in mind that in the original problem, there was an X in the denominator. So whatever happens, X can't be 0, right? So this is called an excluded value. In other words, it cannot be part of your solution set. I don't know if it's going to be or not, but if it is, you have to throw it out. Always keep in mind your excluded values when you're solving an equation that has a variable in the denominator. All right, so what do you want to do with this? I think it's backwards. So it looks like the answers are 3 or 1. Don't need to worry about that. I didn't get 0, so I'm good. The answers are 3 or 1. Easy enough? Yeah. All right, next. Looks like the same exact sort of thing. What do you want to do with it?
Multiply by X minus 4.
So x minus 4 plus 1 equals 0. The nice thing about having a 0 over here is it never changes, right, when you multiply? So x squared minus 4x plus 1 equals 0. It doesn't factor, so you're gonna have to either complete the square, and you could, this would be an easy one, or use the quadratic formula, which is always my personal go-to, but if you want to complete the square, that's absolutely fine. You can do that. Might be easier in this problem. My discriminant is 12, so 2 root 3. And I can cancel 2 plus or minus root 3. And that's okay. Anything but 4 is fine. Your excluded value is 4, but didn't get it, so that's great. All right, C looks like a very similar situation. What are we going to do with C?
Multiply it by the.
Actually, wait, I would start by seeing if you can factor x squared minus 4x plus 3.
I think that's a great idea, Marin. And you actually can. And because this is a rigged problem from the textbook, what miraculously happened? Exactly, which just makes it easier for us, because now when we multiply, what are we gonna multiply by?
X minus 1, X minus 3.
We're gonna multiply by both of them, right? Now, when we multiply by both of them, and I'm gonna write this down, I know most of you aren't going to, but what we are doing is multiplying everything in the equation by the same thing. What ends up happening is, because of the canceling, we end up with just 2x minus 6 here, plus x minus 1 here, equals 2. But I'm not multiplying each fraction by a different thing. I'm multiplying each fraction by the same thing, it's just different parts of it are canceling out. This looks really easy. 3x equals 3. But what?
It can't equal
It
3.
can equal 3. 3 is an excluded value because look back at the original problem. X could not be 1 and X could not be 3. So be careful. Sometimes you go through all this work and you forget, oh my gosh, it couldn't be 3. So no solutions. We did all that and nothing. No. So I'm going to take a page, I'm going to take a page out of Marin's playbook here, and I'm going to go ahead and factor this last denominator. We have another beautifully rigged problem. Don't forget I am multiplying both sides, but since that's a 0 over there, it isn't going to matter. Stop there and have you check it. You got that too? Somebody up there? Okay, so x squared. Chris says no solution again, because aren't both of those my bad answers? Lots of no solutions. That's okay. That's all right. We're okay with that. All right, so that's pretty easy. So now we have a bunch of word problems, it looks like. Some of them look like they're review though for us. So, all right, number 2, how much pure acid must be added to 50 milliliters of a 35% acid to produce a mixture that is 75% acid? Well, we're gonna figure it out, Chris. All right, so we got amount times percent, amount times percent, amount times percent. These problems were in chapter P, chapter 1, and now chapter 2, huh? All right, how much pure acid? What's the percentage for pure acid?
100%.
So right here, it says how much pure acid, I'm gonna put 1.00, 100%. How much? Must be added to 50 milliliters of a 35 to produce a 75. Okay? What am I gonna put here? X plus 50? Because I am mixing X milliliters and 50 milliliters, adding them together. Okay, so 1X plus 17.5. Did you get 80?
Yeah.
Milliliters? Alright, let's get one more done. Here we go, last one. Find the dimensions of a rectangle with a minimum perimeter if its area is 200 square meters. So all I know about this guy is that his area is 200.
Well, what about the length times the width equals 200?
Okay, so if, let's just call this X,
No.
what would that one have to be?
Why?
Well, it could be Y. What else could it be? 200 divided by X. Because isn't the length gonna be 200 divided by the width? Now my job is to find the perimeter of this. Alright, so perimeter would be X plus 200 over X plus X plus 200 over X. That'll be my perimeter, which is 2X plus 400 over X. Would you agree with that? Is that right?
Yeah. But couldn't you find well, couldn't you do like to find X, you could do X times 200 over X equals 200, and you can plug that into the perimeter, because we don't know what the perimeter is.
Oh, you're right. But if we do X times 200 over X, what happens?
Oh, it's just 200.
So no, what we're gonna do now is, we're gonna go to our calculator, we're gonna type in this, and we're gonna find the minimum value. Now, I don't know how your window is set, but you can help yourself out by thinking about, don't we only wanna be in quadrant 1? Don't our X and our P, or our X and our Y have to both be positive? So at least do that for yourself. Now, if you're like me and you type in something and you don't see anything, then maybe your window needs to be changed. Now, the mins and maxes that I used for X were 0 to 50 and for Y were 0 to 400. And it took me 2 or 3 tries to get that. But what I see now when I graph is something that looks like this. And all I need to see is what? What am I looking for? The minimum. So all I need to see is a low point. And as soon, whatever dimensions I have set up, as long as I can see that low point, I am good. So second calc minimum, left, right, somewhere in between. I got 14.14 and 56.57. So what's the answer to the question?
Find the dimensions.
The answer is find the minimum, oh, it says find the dimensions in the least perimeter. So the perimeter would be 56.57 inches, this is my perimeter. And then what would the dimensions be?
14.14.
14, I bet, no, I could be wrong, let's see. What's 200 divided by 14.14? Oh my gosh. so what kind of rectangle should I build to minimize the perimeter? A square. How cool is that? How cool is that? All right, that's it for that. Little human interest story.